This lesson we're going to look at different types of sampling methods and why it's important. So it's often very impractical to survey the entire population of interest, right? Like a census that's done every 10 years. Why is it done every 10 years? It's pretty expensive and impractical. So we usually take a simple random sample of the population of interest in order to sort of gauge what the whole population is thinking or doing. And sampling is a pretty natural thing to do. I mean, think about sampling as something you're cooking, right? You taste, you examine a small part of what you're cooking to really get an idea about the entire dish. So idea one, examining part of a whole. So opinion polls are examples of sampling surveys, right? Designed to ask questions of a small group of people in the hope of learning something about the population, right? Like during the presidential elections, when they sample to see which candidate America is sort of leaning toward, they don't sample everybody, right? They only sample 1,000 people generally. And they are representative random samples from the entire United States, and that'll actually give you a very good sense for what the entire population is feeling. So the professional pollsters, they work pretty hard to ensure that the sample survey they take is actually representative of the population. That is key. So if it's not representative, it can give misleading information about the population. There's a pretty famous election fiasco that was conducted, and we looked at that in an earlier lesson, where they sampled people by telephone to see who they thought would win the election. And as we saw before, this was back in the 30s, and back then only rich people had telephones, and so the Republican candidate was oversampled, right? More people who were going to vote for the Republican candidate were wealthy, and they're the ones that had phones. So people that were going to vote for the Democratic candidate, they were not sampled. They were underrepresented in the sample. And so the professional pollsters, they work very hard that everybody that can possibly vote, or everybody that's involved in the process, is actually in the sample. So some bias. So sampling methods that by their nature tend to over or underemphasize some characteristics of the population is said to be biased, as we saw in the last example I mentioned. It's the bane of sampling. One thing above all to avoid is sampling bias. And there's usually no way to fix the bias sample. Once you've taken it, really there's no way to salvage anything useful from it. And the best way to avoid the bias is to select individuals for the sample at random. That is going to be key for the entire class, that we are going to be taking random samples. The value of deliberately introducing randomness is one of the greatest insights of statistics, and we will discover that throughout this course. So simple random samples. So we draw samples because we can't work with the entire population, right? We need to be sure that the statistics we compute from the sample actually reflect the corresponding parameters, that is the population, correctly and accurately. So the sample that does this is said to be representative. Okay? We want a representative sample. So we will insist that every possible sample of the size we plan to draw has an equal chance of being selected. So no observation, no subject or person couldn't possibly be in the sample. So in the telephone survey they did for president, there were many people who could not be selected, people who didn't have phones. So these samples also guarantee that each individual has an equal chance of being selected. With this method, each combination of people has an equal chance of being selected as well. And a sample drawn in this way is called a simple random sample, or SRS for short. So a simple random sample is the standard against which we measure every other sampling method. And there are other sampling methods that we'll look at, and sometimes we can't do a simple random sample. It's just not convenient. So samples drawn at random generally differ from another, right? I mean, just picture a simple scenario where I had 4 people. We'll just label them 1, 2, 3, 4. If I'm going to do a random sample of 2, and if I just dip in and pick 2, I could pick 1 and 2. I could pick 2 and 3. I could pick 2 and 4. I could pick 1 and 4. I could pick 1 and 3. And there are several combinations. And so if I dipped in and picked 2, you dipped in and picked 2, somebody else dipped in and picked 2, we would generally get different samples, particularly when picture this population being 1 million people or even 10,000 people. We're going to get, and we take a sample of 30, it's very unlikely that we're going to get that same sample, right? Each draw of random numbers selects different people for our sample. And these differences lead to different values for the variable we measure, right? And we call this sample-to-sample differences sampling variability, and we will really dig into that with some examples later on in the course. So a random sample defined, this is the official definition of it. So a sample size, size n from the population, size n. So big N is the whole population. We take a little bitty sample here from them, is obtained through simple random sampling. If every possible sample of size n is an equally likely chance of occurring, the sample is a simple random sample. So that's the official definition. So let's summarize these techniques, and there are some little infographics here to help you visualize those. So here's a simple random sample. So we have a random sample of size n. Subject is selected in such a way that every possible sample of the same size n has an equally likely chance of occurring, right? This is the most basic sample survey design. I mean, drawing names from a hat would be an example of a random sample. So we have this population here, and we pick sample size 3. We got numbers 2, 5, and 9. So that needed to be just as equally likely as if me getting 7, 3, and 1. They each need to have an equally likely chance of being selected. A systematic sample is obtained by selecting every kth individual from a population. So here we're doing every third person. We start with 2, and then we go 1, 2, 3, pick 5, 1, 2, 3, pick 8, 1, 2, 3, pick 11. So it's a systematic sampling. Okay, this gets a little tricky here, and hopefully the visual helps. This is called stratified sampling. And this is obtained by separating the population into non-overlapping groups. So here, the groups are called strata. For instance, here we've got the males in this group and the females in this group. Maybe I really want to make sure that I have, when I sample, I get exactly 2 males, 2 females in this case. And then we obtain a simple random sample from each strata, or stratum, I guess. For example, if I were sending out a survey to MTSU students, I might group them in terms of classification or major first, and then sample from those groups. So a couple of advantages here is that the stratified random sample can reduce bias in this way, because we've selected our groups into more homogeneous groups that of the strata before the sample is selected, and it can also reduce the variability of our results. So the next sampling, I believe the last one we'll look at in here, is called cluster sampling. And again, look at the visual and see how we've done that. It's obtained by selecting all the individuals within a randomly selected collection or a group of individuals. For example, suppose that a quality control engineer wants to verify that a certain machine is filling bottles with 16 ounces of liquid detergent. And to obtain a sample of bottles in the machine, the engineer could systematically sample, say, every 12th bottle from the machine. But this could take a lot of time. But suppose that after each bottle comes off a line, they're placed in the cartons of 12 bottles. They could just measure the contents of all 12 bottles from each carton selected. Now, the cluster sampling is not the same as stratified sampling. We stratify to ensure our sample represents the different groups in the population, and sample randomly within each stratum. The strata, are homogeneous but differ from one another. Clusters are more or less alike, each heterogeneous and resembling the overall population. And we select the cluster to make sampling more practical and sometimes more affordable. And so we see here from our diagram, if we just picture 24 people, and I just sort of grouped the 24 people in each group here, and then I picked that entire group to look at. Okay, and so the detergent example is a good one. You know, sometimes looking at soft drinks or beer bottles, they just will pick off a group, a cluster of those. Sometimes it's just convenient. Like teachers do this all the time when doing educational research. They will just, like all the statistics classes, they will take a group from one or two classes to sort of represent the population. That's also sort of a convenience sampling too that we haven't really talked about. Okay, let's look at some examples here. Classify each sample as random, systematic, stratified, or cluster. And so pause the video here and see if you can look back at your notes and what we've talked about to see if you can do A through D. And each response here could be used none at all or could be used more than once. Okay, welcome back. So part A. In a large school district, all teachers from 2 buildings are interviewed to determine whether they believe the students have less homework to do now than in previous years. So again, all the teachers from 2 buildings. So we have clustered these, right? I mean, just picture a bunch of buildings here. I'll just draw 4, and then this is sort of we got our teachers from each of these. Picture these dots as being the teachers. Those are my people. And then we just pick 2 buildings. Now, this would not be good if like one of these buildings was the honors building, or another building was all engineering students or all liberal arts majors, because that would sort of underrepresent or overrepresent different populations. And so we really want to be careful when clustering that we are really representing the folks down here who were not selected, or only first-year teachers in these buildings. So we really want to make sure that the teachers that are in these clusters are themselves sort of randomly assigned to these buildings. Okay, part B. Every 7th customer entering a shopping mall is asked to select his or her favorite store. So this one should be easy. Systematic, right? So let me write this one down. We had cluster, and B, let's abbreviate this, systematic. Every 7th, every 8th customer entering the shopping mall is asked to select his or her favorite store. And this is sort of, sometimes we use this to avoid bias. The person doesn't just go to people that they're comfortable talking to or something like that. They have to select every 7th customer. Part C. Nursing supervisors are selected using random numbers in order to determine annual salaries. So again, random sample, right? I mean, everybody has an equal chance. We're not systematically selecting every 5th or every 4th person. We're not grouping these. There's just a random number in there. So that's just a random sample. Every 100th hamburger manufacturer is checked to determine its fat content. So this would be a systematic. All right, 100th, every 100th hamburger. Getting the hang of this? Okay, misuses of statistics. So in general, we have bad sampling techniques. And this is the biggest one that we see in newspapers and online surveys, is the voluntary response sample or self-selected survey. You've seen these. They pop up a survey and they say, what do you think about this? What do you think about the new road widening that's coming through this neighborhood? And a lot of people may like it, but who's going to be more likely to respond to that? People in that neighborhood, right, who don't want the road widened. So voluntary samples, one in which the respondents themselves decide whether to be included is terrible. You can really not make any conclusions at all based on that. In this case, valid conclusions can be made only about that specific group of people who agreed to participate. In a voluntary response sample, large groups of individuals are invited to respond, and all who do respond are counted. And they're almost always biased. No conclusions can be drawn from them. Any conclusions drawn are almost always wrong. And they're often biased toward those with strong opinions or those who are strongly motivated to participate in the survey. And since the sample is not representative, the resulting voluntary response bias invalidates the survey. So this is one of the biggest ones that we see, voluntary samples. So whenever you see a voluntary survey, pretty much any conclusions drawn from that, I don't even think about. Small samples. If you're sampling 7 or 8 people, that's way too small. And we will talk about what sort of samples you need in order to be how confident you can be about your conclusions. Convenience samples, really only including individuals who are convenient, right? This group may not be representative of the population. And it's also a problem for students or beginning samplers. It's not only a problem for students or beginning samplers. It's a widespread problem in the business world. The easiest people for a company to sample are its own customers. Now sometimes that's all we have to go on. The convenience sampling is not nearly as tragic as the voluntary response sample. Okay, we've already talked about this in other contexts, but undercoverage is something that occurs often. Many of these bad survey designs, they suffer from undercoverage. Some portion of the population is not sampled at all, has a smaller representation sample than it has in the population. And so that invariably leads to a potential source of bias. Long surveys. You don't want to bore respondents with surveys, go on and on and on. If they're too long, they're more likely to be refused, and that reduces the response rate and biases all the results. I know I get sent surveys all the time to fill out, and if it's going to take me more than an hour to fill out, I just don't have time to do that. So if I've got a 100-question survey, if they're not multiple choice, all essay, unless I'm getting paid to fill this out, it just does not get done. So I'm a person that would not do that. So they're going to be, people like me would be underrepresented. People who don't like filling out long surveys. So example, name and describe the kind of bias that might be present if the statistics teacher decides that instead of randomly selecting students to survey on how they feel about the course, she just, part A, asked students to volunteer for the survey. So what sort of sampling, what sort of bias would occur here? Voluntary response sample, right? It would probably be toward those students who say they enjoy the course, or students who say they really hate the course. Or just gives the survey during class one day. So this is a convenience sample. It would probably be towards students who happen to attend class that day. And students who attend class, if you ask them how they feel about class, people who are coming, maybe you're underrepresenting those who aren't attending class. So if one of your questions is how valuable is class time, people who are in class are probably going to think it's more valuable than someone who's not in class, the group who's not in class. So you just have to be careful about that. Sometimes that's all we got, and that's what a lot of research is based on. So there's a lot of limitations with the conclusions that are drawn. Another example, a statistics teacher wants to know how her students feel about an introductory statistics course. She decides to administer a survey to a random sample of students in the course, and she has several sampling plans to choose from. Name the sampling strategy in each. Okay, so we've kind of looked at these before, but go ahead and pause the video here. So we're looking at stratified, cluster, simple, or systematic. So pause the video here and see if you can get these to come out. Okay, welcome back. I know you paused it. So at the very least, hopefully mentally you go through these. There are 4 ranks of students taking the class freshmen, sophomores, juniors, and seniors. Randomly select 15 students from each rank. So this is a stratified sample, right? We stratified each strata are the classifications. Okay, part B. Randomly select a class rank, freshmen, sophomore, juniors, and seniors, and survey every student in that rank. So again, let me write this down. This was the stratified. Stratified, just abbreviate that. And what is this one going to be? Here we group them all in the freshmen, sophomore, juniors, and seniors, and then we just pick one of these. So I may pick all the sophomores. That is the cluster sample. Hopefully you see the difference now between the stratified sample and the cluster sample. Cluster, we first group them up and then pick everybody in that group, in that strata. Stratified sample, we break them up and then we randomly select a certain number from each strata, not the entire strata or stratum. Okay, part C. Each student has a 9-digit number. Randomly choose 60 numbers. Random sample, right? Let's abbreviate that. Random sample. And using the class roster, every 5th student from the list. Hopefully that's easy. That's probably the easiest one. Systematic. Okay, last example, I think. Explain why the second plan suggested above, sampling all students from one class rank, might be biased. And sort of name the bias here. So under coverage is certainly one bias that could happen here. Class rank selected, it may not be representative of all students in the course. I mean, if you pick all the freshmen, freshmen definitely have different ideas about courses and expectations than seniors do. I mean, just from levels of experience, right? So that technique, as I was reading through that, this is the one technique that I think would be harmful for doing it. The other ones seem like they would work out, right? Part A has its benefits because we're sort of guaranteed to get 15 from each group. And the problem here is, what if you only have 10 freshmen in the class? And that becomes more difficult. Random sampling, certainly nothing wrong with that. And every 5th student, that one looks fine too. Loaded questions. Another misuse of statistics. So should the president have the line item veto to eliminate waste? Well, everybody's going to say yes to that, right? But this is kind of a loaded question, right? To eliminate waste. If you just asked, should the president have line item veto or not, we got a 57% yes. So these are done very sneakily sometimes in political polling, so you just have to be really careful with that. About every year seems to be an election year, so be on the lookout for these types of questions and polls.